Hello, water managers. My name is Matt Fleming. I'm part of the Water Management Systems Division at the Hydrologic Engineering Center. And in this video, this is the final video of the CAVI orientation presentation, and we're going to talk more in depth about the different modules within the CAVI. We'll talk about each of those modules and really focus on the purpose and use of those modules and then available tools specifically within the modules. All right, when logging into the CAVI, you have at least two options here. One option is if you want to connect to your specific CWMS database, then you'll need to provide that information via what server you're logging into and then a certificate so you can be authenticated when you log in. The other option is if you just want to log in locally on your computer, you don't have to choose a server. There's just a local option. And in that case, there's no authentication that's needed whenever you log in. All right, let's go into more detail about the data acquisition module. This is where you can view the status of the different data streams that you have set up in your CAVI watershed. The status for each data stream is represented by the color of the corresponding button on the control panel. The last data stream status shown in the alert message line. So you have different messages down here. You can see that information as well. You can view the status and the quality of data for individual gauges, right? So all of those gauges that you've set up on the Setup tab should be displayed in the data acquisition module map right here. You can zoom in or zoom out and locate those individual data streams. The quality color bar time series reflect the data quality at primary gauge locations. And then the time window is important too, because the time window is what's used to evaluate the data that's being displayed in the acquisition tab. You have two different options for setting the time window. The option at the top of this figure here is relative to the current time. So if you want to look back just 3 days from the current time window, you can check that radio button and choose a look back of 3 days, hit the refresh button, and then after you do that, these bars, the information that's feeding these bars should reflect the last 3 days. So that's the relative to the current time option. The other option that you can choose is the specific time window option. And here you would specify a start date and time and an end date and time, hit the refresh button, and then the information that's loaded for these icons should be specific for that time window that you define. You can also validate or edit the data for the gauges. So once you've defined the time window and pulled in the information that you want to visualize, you can hit the data validation button here and a new editor will show up, allowing you to visualize the time series data and then possibly edit if you wanted to. There's a data status summary table here that you can also bring up from the acquisition tab. You can see the quality bars here. There's one column with those. And then you can see another column for missing data, and then also time of last value is displayed as well. So this is a nice summary tab that can be used to help evaluate data at all the locations and if there are any issues that you need to address before you start modeling with that data. This last bullet is really important too. So some of the models in your compute sequence, and we'll get more to that in just a minute, some of those models are going to require data at specific time steps. And it's really important whenever you set the time of forecast or your simulation time window for the forecast that you know if you're missing any data at key locations. One example might be reservoir outflow during the look-back period. ResSim is going to need that information to help drive the simulation in the look-back period so that you can use this summary status table here to see if there is any missing data for specific time series, so reservoir outflow, and if it is, this is going to be your opportunity to quickly see that, and then you can use other tools to go in and edit the data. Here's the data validation editor. So it's a combined graphical and tabular editor. So you can see the figure here. So this is your graphical view of the data for this time series. And you can use different toolbars or tool options here to modify the data. There's a graphical option where you can click that button there and start manually defining the time series data. Or if you don't want to define the data graphically, you can always enter information in the lower half of this editor in the table view of the data. There's other options for filtering based on the quality of the data, and then you can also plot information from other gauges for comparisons too. So that's the data validation editor. Let's switch from acquisition to validation, or sorry, acquisition to visualization. So in the data visualization module, this is where you can go to visualize gridded information. So if you've downloaded a precipitation grid from Cumulus, or you have another data set or somebody else has provided information in gridded form, you can load that into the data visualization module and then use the buttons or options that are available to visualize that storm in time and space. So that's available to you on the data visualization tab. For gridded data, you can also visualize the time series information too. You'll notice on this figure here, the different time series icons, the information for those time series icons is represented by thumbnail plots. So you can get a little idea for what the data looks like for the time window that's defined. If you want to see more information, you can always right-click on one of those thumbnail plots and then visualize the information. Within the data visualization module, you can also set up threshold color bars. And these threshold color bars are just options for you to visually see if different ranges that the data might be in. For the example that we have here on the bottom right for a stage gauge, you can see that if stage values are greater than 1.8 feet, I'm guessing, then the bar color will be blue. If the stage range is, or if it's less than 1.8 feet. If it's between 1.8 and 1.95, dark green, 1.95 to 1.97 yellow, and greater than 1.97 is red. And so it's just a quick visual cue to let you know what the values in the watershed represent. All right, let's move over to the modeling module. This is where you're going to interact with the different numerical models that are part of your compute sequence. The figure on this slide is a little dated. In this compute sequence, we're using MFP to drive the meteorology for these simulations. We should have a figure in there that shows us using METView, right? That's now the processor for meteorologic data. But you can see the different compute sequences here. So we have two forecast runs that we're simulating within the forecast time window. We have both of them are using a standard sequence of MFP, HEC-CWMS, HEC-ResSim, HEC-RAS, and then HEC-FI. You can customize the compute sequence. So if you want to run just METView to HMS to ResSim, that you can have a compute sequence with just those three models. Or if you want a compute sequence that really just drives ResSim. So you have some kind of National Weather Service forecast, and you want to use that as your boundary condition to ResSim, then you can have a ResSim only forecast compute sequence. What you can do with the different compute sequences, if you want to take it all the way through FIA, then you can determine your inundation areas or your flood depths across the watershed. If you just take it through ResSim and you want to focus on your reservoir operations, then you can do that. You can evaluate the economic impacts from different floods. So if you want to see the flood damages reduced from projects in the watershed, then you can run it all the way through HEC-FIA to get the impacts from the economic impacts that the reservoirs provide in the watershed. You can also do what-if scenarios if you want to use HEC METView to move the storm or to increase the precipitation depth from the storm. You can use METView to create these what-if alternatives and then run those through the other models to see how the impacts from those changing storm characteristics are in the watershed. Also, results from these simulations can be posted to the CWMS Oracle database when you're finished. Mentioned this just a few minutes ago, so the different models that are available to run. So meteorology is going to be HEC-METView again, hydrology HMS, reservoir analysis or reservoir simulation ResSim. Hydraulics is going to be the RAS model in your compute sequence, and then finally economics FIA. You can visualize your inundation maps with RAS Mapper, or you can also visualize those within the CAVI map window when you're selecting the modeling tab. You can visualize different results from the models. So after you've run a compute sequence, you can see the results directly from the CAVI. You don't have to open up the native user interface for the different pieces of software. All the results are going to be available to you from the CAVI. All the results from the simulation or your forecasts are going to be saved to one DSS file. It's the forecast DSS file for that specific forecast that you created. And all the results that are saved in that forecast DSS file, they can be accessed through SWMS view. There's an option to open that data, the DSS file using SWMS view. And then some of the data is going to be available to you through the map window. The CAVI also has tools that are available to you for editing the different models that are part of your compute sequence. So if you need to calibrate the HMS model to the look-back period, then you can access the native HMS calibration tools for a forecast alternative directly from the CAVI. You can also access editing tools for HEC-RAS, for FIA, for METView directly from the CAVI too. So if you want to do those what-if scenarios or perform calibration, all of those tools should be available to you directly from the CAVI without having to go through those native model user interfaces and work with them there. The setup module, this is going to be the most important module for really configuring how your CAVI watershed works. Within that setup module, you can load your background maps. That's where you would go to import your models, set up different run alternatives, linking models together. There's going to be more discussions in future presentations here about linking models, but that's one step where you'd go to the setup module, and once you have the different model applications like HMS, FIA, and whatnot, once you have those components added to the SWMS watershed, and you've defined alternative keys, and then you've set up forecast runs, that's when you would go in and start linking those different model data to one another so that you could run a sequence from METView to FIA. And then also that's where you would go to build your extract and post list. So the extract list is really important because that's going to be used every time you create a new forecast. That extract list is what's used to get the data that's needed for that forecast. If you need to go to Cumulus to bring in your precipitation grids, then you would configure that within an extract list. If you need to go to different databases to pull in time series data, that's going to be included in the extract list as well. And then your post list is when you're finished creating your forecast and you want to write results back to the SWMS database, then you would configure that within the post list. And then finally, your time series icons, that's where you would configure those. You would add those to the map and then identify the data streams that are associated with each of those time series icons. All right, we made it to the end of the CAVI orientation presentation. You can see the links on this slide for additional resources, and I wanted to thank you for your time.